So now it's my great pleasure, a little bit late, albeit, but we do have a break that now we're going to blow through. So sorry about that. To introduce our keynote speaker. And I love the fact that in Germany, you get all of these titles. So I wasn't sure which one was the most important, but I know they are all indicative of the fact that Andreas Fink is a real leader in our field. So Professor Andreas Fink is a distinguished psychologist and neuroscientist at the University of Graz in Austria, where he serves as a professor in the Institute of Psychology's Biological Psychology section. He's internationally recognized as a leading researcher in the neuroscience of creativity, with particular expertise in using EEG and neuroimaging techniques to understand the brain mechanisms underlying creative cognition. He has an impressive publication record with over 300 research publications, and he was not able to be with us yesterday because he was winning a mentorship award. So congratulations, Professor Fink. And just to give you a sense of what he is going to talk about, over the last decades, the neuroscience of creativity has undergone significant advancements. Since Colin Martindale's pioneering work on brain oscillations underlying creativity, the field has grown in many different directions, revealing important insights into how creativity manifests in the brain. And so this talk will explore these perspectives and emerging trends. And Dr. Fink, we are delighted to have you.
So I will already start. Thank you very much for this nice introduction. I'm so excited to be here. It's so great. So thank you very much. I feel deeply honored. The title of this conference, Creativity and Changing Brains, perfectly reflects the current state of research in the field of creativity. You can understand me? That's great. Okay. First, the title Changing Brains indicates that neuroscientific approaches are expanding. Today, we are not only limited to EEG or functional imaging. We have also other measures, such as measures of biochemical information. We have psychophysiological measures. Does it work?
Yes.
Okay. Biochemical measures. We have psychophysiological measures. We have also analysis of hormone levels. So this direction has expanded to a considerable extent. The second point is changing brains in the context of creativity also indicates or highlights that creativity is a highly dynamic construct. The brain shapes creative behavior and creative experiences reshape the brain. So it's important that we understand the mechanisms behind. So what specific mechanisms shape our brain and creative behavior, and this makes this conference so exciting. I would like to share some ideas on this topic with you, and before I start, I will briefly introduce ourselves. Our research lies at the intersection of human movement science, psychology, and neuroscience, and we use knowledge and methods from psychology, psychophysiology, and brain research to explore and better understand the various mechanisms implicated in affective and cognitive functions. And physical activity is among the most important methods we study because it has been found that physical activity is not so important for physical health, but also for mental health, for creativity. It is also exciting to see that physical activity has many effects on functional and structural brain characteristics, and in turn, these brain changes also change creative behavior and changes in cognitive function. So you would ask, what has someone like that to do on a creativity conference? And I would say quite a lot. Movement and creativity are closely connected. And many of you might have noticed that you often come up with great ideas when you're moving or physically active. This is Graz. And this is my running route. And from this point, I can see our university. And I must always think that I do not have the most creative ideas in our lab. Much more likely when I'm out here. And I think this is the biggest difficulty we challenge in creativity research, because we have to investigate a construct that is so difficult to assess in the lab. And in my presentation, I will briefly share some thoughts how we can manage this big problem. Okay, physical activity and creativity is one important area of research, but the main emphasis of our research has always been the neuroscience of creativity. We use different methods from biological psychology, from neuroscience, from psychophysiology to better understand the mechanisms implicated in cognitive and affective functions, especially in creativity. We are especially interested to look at creative behavior that is more closely related to everyday life. A specific example is, how can we use creativity to cope with stressful situations, like dealing with feelings of anger or fear. And a last point of research is creativity enhancement. So we also explore brain measures and other biomarkers to better understand the mechanisms that are implicated in any changes. So the creativity research is so complex. We all know it. And the fact is that this research has made an incredible transformation. And one important milestone in this field was the work of Colin Martindale. About 50 years ago, the neuroscience of creativity also arrived in the neuroscience lab. And Colin Martindale, you won't know him, but he did very influential work in this field. He was the first to discover that creative cognition is associated with a characteristic pattern of brain activity. And his discovery that that creativity is associated with EEG alpha activity has stimulated a very, very interesting line of research that is still very much alive today. This is University of Graz, about 2005. You probably know this guy here. We were sitting in our lab and thinking about possible ways, how could we assess creativity in the lab? The problem and with what tasks. The biggest challenge we faced was not which task to use. The biggest challenge was, how can we implement this task in the EEG lab? Okay, and these were the very first efforts in this field. This field began to grow in different directions, and experimental tasks and paradigms have much improved over time. And as so nicely expressed by Carl Stevens and Daria Sabelina, creativity has come in waves. And to provide a very brief summary, the EEG alpha findings tell us three important things. First, these findings have often shown that creative cognition is characterized by different patterns, by different time course of alpha activity patterns over the creative thinking process. So creative cognition is a highly dynamic process. The second aspect was that creativity is no mystical event. It can be integrated in well-known cognitive functions such as memory, attention, and cognitive control. And the third point that is especially exciting is that evidence was also, as highly relevant studies have demonstrated that there could be possibly also a causal role for EEG alpha activity and creativity, because these studies used TAZS a method, you can modulate alpha activity, and then you can look, are there any changes in creative behavior? And this was a direct evidence that there could be a direct role of alpha activity in the context of creativity. So not only EEG studies have provided great insights into creativity, of course, there were also excellent efforts to study creativity in the brain imaging scanner. And the first studies in these fields were mainly focused on studying creativity using divergent thinking tasks like the alternative uses task, but this field rapidly expanded to explore creativity in more real-life creative processes such as piano playing. And this was the very first study, the very first published fMRI study on creativity. And this study was strongly concerned to link specific facets of creativity with specific brain areas. And this view has completely changed. And nowadays, it is well recognized that creativity is organized in different networks, in multiple brain networks that facilitate creativity. And the fact that creative thinking ability can be predicted by functional brain connectivity, even across different cultures, this was another important milestone in this field. And the reason why I pay attention to this important study was that this was, in fact, one of the first studies published in such a high impact journal. So this opens the door for the advancement of modern neuroscience research in the field of creativity. And I think this is a really great work. Thank you, incoming president. This was really a great piece of work. Okay. Now, about 3,600 papers are published on creativity in the brain. I did a careful literal research as about 3,600. And what is very interesting in this picture is that we can observe a very sharp increase after 2010. So what has happened during the time? Do you have any ideas? Yes. That's exactly great. But this is only one point. The second point was that, okay, this is the first point. The second point is that the greater availability of EEG technology and brain scanners, of course. And a third reason was that was also the time where the first meta-analysis on creativity and brain were published. And these meta-analysis showed a very disappointing picture. And I was really frustrated at the time because these meta-analysis said there is creative thinking doesn't appear to critically depend on any single mental process. We found little clear evidence and so on. Creativity does not depend and so on and so on. These conclusions were really disappointing and demotivating. At the same time, these studies were also an important wake-up call for the community. And very soon after that, this field agreed upon some common approaches. As a first, studies used well-proven, well-tested tasks to assess different facets in the lab: verbal creativity, figural creativity. Studies use clever setups to isolate critical thinking stages from phases that are that could interfere with motor responses, for example. And an important thing was also that studies included task performance measures. So this is the most important prerequisite that we can link creative behavior with brain activity patterns. And this was really an important prerequisite that the field could move further. So now we have 2025. We are convinced that this field will continue to grow and will provide exciting evidence, but in which direction? It's almost impossible to filter out the most promising direction because there are so many outstanding contributions. There are so many rising stars. This hall is full of rising stars, and it's really impossible to anticipate where creativity research will develop. But if we take a closer field on ongoing research activities, we can probably identify some regions that could be of special interest. First, there's growing interest to expand creativity into more real-world application. Second, there is no creativity research without training of creativity. The third point is we do many neuroscience studies, we do many studies on creativity training, but we do not always ask what we are really measuring and what changes in the brain. It's also important to think about this critical aspect. Modern neuroscience must also include a gender-sensitive perspective, and the last word has AI and machine learning. And I will briefly share my ideas with you. The first point, the field has grown, has exploded in this context. As there are many different approaches available now, which focus on musical creativity, creative writing, drawing, design creativity, and so on. And these studies, which try to expand creativity into more real-world behavior, are so important because they bridge a gap between lab research and practical implications. And this is really important for creativity research because such findings could potentially inform the use of arts-based therapies, for instance, and especially in the context of visual artistic creativity. This is a very important practical implication. Another exciting line of research is group creativity. Creativity is very often teamwork. Imagine a typical brainstorming session. Group of people is sitting together and they are thinking about ideas, how can we improve something? And such group-based techniques are usually very effective because each single idea a person generates stimulates new ideas in other persons. So group creativity techniques are effective, as more effective than single brainstorming sessions, as a brainstorming session with single individuals. And there's a fascinating line of research studying interpersonal brain activity while a group of people is engaged in any kind of social interaction. For example, in this case, in a brainstorming session, such studies are called hyperscanning studies. And there's fascinating evidence, first evidence, okay, this field of research is at a very early stage of research, okay, but it's exciting to see that these studies point to some interpersonal coupling of brain activity while a group of people is engaged in creativity-focused discussions. It's exciting to see. Another type of creativity we experience almost every day is creativity in dealing with emotions. For example, how can we use creativity to cope with stressful situations? How can we cope with anger? How can we cope with fear? Here can we use creativity to reappraise these feelings in a new and constructive way. Creativity is not always used positively. Corinna Berthold-Stephan did excellent work in this field. Creativity can also be used to harm other people. And this represents the more darker facets of creativity. And I feel much more comfortable with the more positive aspects of creativity. So let's briefly show you an example. Imagine a bus just drove away in front of you. That's really annoying. But what can we think about this to reduce our anger? And what can we do? As we can take a deep breath. We can take a break. The next bus will come soon. Or as we know, that's so good for creativity, we can take a walk. And so this way, all the negative feelings are away. A great method neuroscience studies showed that, as EEG studies, functional imaging studies, that compared this kind of creativity, as emotional creativity, with conventional idea generation in the alternative uses task. These studies show a very strong overlap. This was to be expected because there are many shared cognitive processing demands, but these studies also show important differences because when you are thinking about emotional situations, you also have to regulate an ongoing emotional response. So this is also very important in this context, and here we also saw critical differences in brain activation. Another excellent and fascinating example to extend creativity into more real-world behavior is soccer. You won't believe it's soccer. Who is a soccer fan? I think, okay, someone, it's great. Okay, nice. Okay, soccer has so much to do with creativity. You won't believe it now, but I will explain it. In order to be successful in soccer, you do not only need to be physically fit. You also need cognitive functions such as creativity. As you must be original, you must be surprising. This is perfectly what, at the same time, also effective. And this is exactly what standard definitions of creativity include: usefulness and originality. And in order to be successful in soccer, we also need cognitive functions such as attention. We need to attend to opponents, the player of the own teams. Also, we need to retrieve information from memory. Also, we need to inhibit the most obvious move and so on. There are so many cognitive functions implicated in thinking about creative solutions in soccer game situations that display a very, very obvious overlap to conventional idea generation. You won't believe it, it's also possible to play soccer in the scanner. In this study, participants were shown brief video clips of soccer situations, and participants were instructed to imagine themselves as the player of the attacking team. And the final frame of this video clip was frozen, and this marked the beginning of the idea generation phase, and participants now had to think about creative solution. How can they continue this situation in order to make a goal? And what we did here is, as after the experiment, as the responses were also recorded afterwards, and what we did after the experiment, as we assessed creativity of the solution according to predefined categories, and we used the machine learning approach to predict the creativity of responses on the basis of the brain imaging data. We found this that many brain networks that we know from conventional idea generation, as a visual networks that support semantic memories, all of these networks were also implicated in this kind of creativity. The second point, exploring creativity enhancement techniques is so important because we need a stronger we need a stronger orientation into the practical domain. So this field is currently experiencing broad diversification. Bromoticon creativity has been analyzed in many different contexts. There are so many different approaches, as ranging from enhancing creativity via divergent thinking training, positive affective states, cognitive stimulation, and most strikingly, even after drinking tea and after sleep. And new findings on sleep and creativity are especially exciting. Also, we don't need to stimulate us cognitively, as only sleeping is okay. As this study found that briefly dozing off for at least 15 seconds increased the chance that a hidden rule was detected, while this effect was not apparent when participants reached deeper stages of the sleep. So this is great. Okay, we do not really understand the mechanisms behind, but this is on the one hand great to see that so many different approaches seem to assist, so many different studies. And it seems that at least some facets of creativity can be trained effectively. But on the other hand, the problem is that there are so many studies that seem to live in isolation, and there are almost no replication studies. And we had a very similar situation in 2010. Meta-analysis draw a mixed picture. Okay, this is the largest meta-analysis on creativity enhancement today. About 169 studies revealed a moderate training effect of 0.53. Okay, that's okay. But there's also a very strong publication bias, and there are also methodological problems in almost all studies which use intervention designs. And another problem the authors noticed was that most of the studies used only one divergent thinking as a single measure to examine the training effects, and this is not satisfying. If we narrow down the studies into studies that use cognitive stimulation or divergent thinking training, and studies that used other biomarkers or brain markers as a tool for assessing creativity, the picture becomes somewhat clearer. And the great thing of this study is that they were able to show that brain markers are so important in assessing the efficacy of the effectiveness of a training, because they reliably indicate changes in cognitive functions as a result of divergent thinking training. And I think neuroscience methods and other brain imaging methods and other psychophysiological methods, other methods from biological psychology are so helpful in assessing the effectiveness of existing trainings. Okay, another point is that physical activity. We talked about this already today, as a physical activity is also a strong candidate for creativity enhancement. As we found effects of about 0.50. There's a moderate effect. We found that chronic physical activity is better than single parts of walking, for instance. And as is the case in almost all intervention studies, we have to notice that there are really severe problems in study protocols. So, okay, someone likes sports, other not. Let's try with walking. Walking is a very easy strategy to enhance creativity. This study assessed the number of steps in everyday life and creative ideation performance in everyday life, and found that walking is a great boost for creativity. And the more you walk, the better it is. It's great, because we don't need to do sports. It's perfectly enough if we walk a bit in everyday life. And this highlights the promising role of walking as a health promoting activity, also including enhancement of creative thinking ability. So a completely different thing. No sports, or only a bit of sports, but perhaps much more cognitive elements. Dancing is a great example of this. Some people like sports, the other one like cognitive stimulation. And we can combine these things. Cognitive stimulation and physical activity, and dancing is a great example of this. Dancing is not just a physical activity. Dancing is a multi-domain activity. It involves many different events. It includes cognitive functions such as attention, memory, cognitive control. And it is also fascinating to see that dancing drives functional and structural brain characteristics, and in turn, these brain characteristics, also these brain changes, also drive indicators of mental and physical health. I'm so sorry that we have no data on this topic today, but we have an interesting project in this field, which is currently going on in our group. The basic idea of this project is that we look at brain changes and changes in affective and cognitive functions as a result of a dancing intervention. And the critical manipulation in this study is the dance style. Dancing is not dancing. There are different types of dancing. And what we want to assess as the participants are randomized to 3 different groups: a contemporary group, classic ballet group, and a waiting control group. And all participants are tested at 3 time points of assessment. They underwent functional brain imaging, psychophysiological assessment, psychometric assessment. At the beginning, after 3 weeks of dancing, and after 6 weeks of dancing. And the critical manipulation is that we compare 2 different dance styles, ballet and contemporary. These are Anna and Sandria, 2 passionate dancers, at the same time also highly motivated PhD students of our groups, and they lead and supervise the dance interventions. And as you can see in this video clips, ballet is a very strict and formal dance style. It requires a very strict movements. On the other hand, contemporary dancing is more free-flowing. You have greater room for improvisation, for instance. In fact, they are completely different dance styles. And what we expect here is that the contemporary dance group should drive other brain networks than the classic dance training, than the ballet training. And we also expect that these more strict, this more formal dancing style should modulate other cognitive functions than the more free associative contemporary dance style. In other words, we expect also that the contemporary dance style should potentially also affect some facets of creativity, especially also in the figural domain. Okay, we do many neuroscience studies on creativity training, but we do not always ask what do we really measure, what changes in the brain. When we look at brain correlates underlying creativity, we often look at gray matter changes. This study found, for instance, that the originality facet of creativity is associated with the precuneus and the caudate nucleus, and it's great because we all know that the precuneus is implicated in default mode network activity. This brain region is also implicated in self-referencing processes. We also know that the caudate nucleus is also a critical candidate in creativity. But what we must notice is that gray matter volume is a very abstract and a very global measure. And we do not really know what gray matter really includes. Histological studies indicate that gray matter is not only composed of cell bodies of neurons, as we know that we also have processes related to glia, angiogenesis, and the changes we observe in creativity training studies, changes in gray matter, can be due to changes in any of these components. So the gray matter changes do not tell us anything specific to creativity. These are very, really very global measure. So sorry when I provide some details here. If we wish to have more detailed information about the brain changes we observe in our brain imaging studies, we can use magnetic resonance spectroscopy. And this is a very complex technique and a very intense technique, which allows to assess biochemical information in the brain. We can assess some key neurometabolites which inform us about normal brain functions and which inform us about pathological states. For example, NIA is a marker for general brain health. We can also obtain information about neurotransmission, with GABA being the main inhibitory transmitter, and glutamate being the most prominent excitatory neurotransmitter in the brain. So if we include such measures in our studies, we would be able to get a more comprehensive picture about the brain changes we observe. We had a very strong focus on gray matter changes in our studies. Almost all studies as a focus on gray matter changes as a result of creativity trainings, and there are almost no studies which focus on changes in white matter, and this could also be an important way to study how our brain changes as a result of training. And there's a fascinating line of research showing that the process in which oligodendrocyte precursor cells proliferate and differentiate into oligodendrocytes and establish new myelin, as this is achieved within an hour, and a length and thickness of myelin further increases as with time. And it's not possible to directly assess the degree of myelination with human brain imaging method, but there are exciting new approaches in this field that can be very helpful for creativity research. For example, pixel-based analysis. So we can look at pixel instead of voxel, and pixel are small fiber bundles, and such fiber bundles that tell us important things about fiber cross-section, for instance, density of fibers, and so on. And these measures have mostly been used in a clinical context so far, but I think they could be of special importance in the creativity domain, because we always know, as a Yoet did so much, so great work in this field. Roger did so great work. We know that creativity is facilitated by multiple brain networks. But essentially, all these studies came from the functional imaging domain. So it would be exciting to see or to extend these findings also to structural brain imaging, because this would be a very, very nice way how we can complement this line of research. Okay. Sorry, once again, I don't have data for the creativity domain, but what we found is that these novel measures of structural white matter plasticity are highly sensitive to motor learning, such as learning to walk at a slack line. And this is great to see, because a control group didn't show any changes from the pre-test and the post-test, while the people who learned to walk a slack line, this was the case after 3 weeks. So this group of people showed increases in fiber cross-section. The orientation dispersion of the neurites changed significantly. And that was great to see that these measures are sensitive to motor learning. And what could be interesting for creativity is that motor learning also modulates, or could also modulate visual spatial information, spatial cognition, for instance, and perhaps also figural creativity. It would be great to see specific research in this direction in the next future. Okay, now let's move from the slackline to more gender-sensitive research in creativity. The investigation of gender differences in psychology and neuroscience is is very fascinating. At the same time, also a very difficult area of research. Are women indeed more emotional? Are men more aggressive? Which is the smarter sex? Or are there any sex differences in the brain? Or is there even a sexual dimorphism that would justify such conclusions? I would say no. This is one of the largest meta-analysis in this field. This study included about 2,500 women and about 2,500 men. And these participants were compared with respect to gray matter volume, surface area, and cortical thickness. And if we have a look at the first the left side, as we can see that there are strong differences across different cortical subregions, as a differences in gray matter volume, with more volume in men than women, as a men also have higher surface area and women have higher cortical thickness. But, and this is the critical step, if we control for mean gray matter volume and mean surface area and mean cortical thickness, no sex differences are available any longer. So there's no indication that there is a strong sexual dimorphism in the brain. So what about in the creativity domain? Are there any gender effects? And excellent studies in this field came to the conclusion it's naive and wrong to suggest that there are there are absolutely no differences between both sexes, but there is also no evidence that one gender is more creative than another. Okay, the true story appears far more complex. So many of the sex differences we see in the brain and in behavior might probably be influenced by sex hormones. And at first glance, this might seem surprising, sex hormones in the brain. Yes, there are more and more studies indicating that sex hormones like estradiol have a strong impact on affective and cognitive functions and on mental health indicators. Let me share a fascinating study with you. This study found that women were more original prior to ovulation as compared to other stages of the menstrual cycle. And the authors discussed these findings in terms of signaling theory. So this originality boost could probably be helpful to increase mate attraction. They discussed these findings. But looking at this finding more broadly, we can also discuss the role of estradiol. So estradiol is relatively high prior to ovulation compared to other stages of the menstrual cycle. So this originality effect could also be driven by sex hormones. So this is actually what studies in the animal domain indicate. As they show that the brain, as a specific sub-region of the hippocampus, changes the intensity of spine synapses across the sexual cycle of rats. And this is interesting because the spine density is highest when the levels of estradiol are highest. And this is a great finding, but we are curious whether we can find a similar pattern in human fields. And we are also very curious whether we could link such findings also to corresponding changes in affective and cognitive functions. So about 20 years ago, no one would have taken this idea seriously. But I think now the time has changed, and I think we should have a look. We should try it as what we test in an ongoing project in our group is, are there any differences in affective and cognitive function, especially also in creativity functions across the menstrual cycle, which are characterized by different levels of hormones? And in this study, women are not only expected to be more original prior to ovulation, they should also show the corresponding changes in mental health parameters, as fewer depressive symptoms, greater positive affect. And we also expect that these changes are driven by changes in the brain, especially in the hippocampus, given its prominent role in affective and cognitive functions. Okay, and I'm already in the at the last point. The last word in my presentation has IA, machine learning. And there are two examples. There are two examples that are especially important first, as approaches that use automated scoring in psychometric assessments. The psychometric assessment of creativity has much improved over time, of course, but through machine learning approaches, this research line has made an incredible transformation. As studies use semantic distance language models, these studies try to validate these findings across different cultures. I'm so sorry that I can provide only a brief excerpt here, but this research line is of highest potential for the future, and I think the better we know how we can assess creativity at the psychometric level, the better we know to understand creativity at the level of the brain. And the second point is that has greatly transformed in the neuroscience of creativity is data analysis, especially the identification of characteristic pattern in large data sets. So in a typical cognitive neuroscience experiment, we have imaging data, usually from different modalities. So we have functional imaging data, we have structural imaging data, we have resting data, and so on and so on. We have physiological data, and we have also psychometric data, creativity data, and so on. And instead of analyzing them separately, we can combine them. And here plays artificial intelligence a key role. So it helps us to find patterns, to organize, to structure the data. It helps us to find solutions. It helps us to find characteristic patterns and so on. And the other side is that such IA approaches, machine learning approaches, can also learn from the brain how it works and learn from the mind how it works. So mind and machines are learning from each other, and together humans and machines can advance our understanding in creativity in new and powerful ways. And so just as mind and machines are connected, so are neuroscience and creativity. And I think what Colin Martindale has started 50 years ago continues to inspire us in future. So thank you very much for your attention.
So thank you very much. I think as we're resetting for the next invited talk, we have room for one question. So make it a good one. Okay.
Thank you very much for your talk. I have a couple of questions. So we have been talking about creativity, and I wonder whether we should instead be talking about the creative process. And because we collaborate with artists, and they tell me that, you know, it takes time, and you never know when you are done with the piece. You know, there are many factors, right? So process versus creativity, right? And which alludes to the need for longitudinal studies, right? And ecological settings. So I'd like to get your opinion on that.
I got it right as a you. So we should take a closer look. Sorry. I tried this one. Okay, we should have a closer look at the processes. Yes.
Yeah.
Yes, I think neuroscience must look at the processes. And I think EEG techniques and brain imaging techniques also provide excellent possibilities to look at creative processes. And I think that's the future, yes, of course.
And about the need for ecological settings, because the fMRI studies have provided insights, but it provides also very strong constraints, right? So, and I know this is a challenge, and I wonder, where we should put more attention to that.
Yeah, that's one of the most important challenges we face every day. How can we transfer the findings of lab research into the practical domain? And this is exactly what we face almost every day. And I think as we have to use clever setups which allow to assess brain activity patterns in more real-world applications. For example, we can also use other methods. So we must not only think about EEG techniques as a brain imaging data. There are also many other approaches in the neuroscientific research of creativity available now.
Great, thank you.